So let's first go through the single user scenario. Basically, you're the only developer, the only user of your repository. So you can set up a local repository. Typically you don't need to do that because basically you would clone an existing remote repository. But if you need to set up a local repository, no problem. So a little bit of configuration is necessary anyway for your local client. So basically you would set the username, and that would be your actual name, and you set that globally. That's what the -- global does. The git config will just rewrite your git configuration file for you. And you also set your email address. Again, that's global configuration. And if you like, you can also set your default editor. So in my case, that would be Vim, but you can of course take anything, for instance Nano, whatever you prefer. For GUI clients, basically you set that through options in the preference menu, and you can do the very same things. So to create a repository, first you would of course select a directory to store it in, and if others need access to that repository, which I would not recommend, but okay, then the directory should be group readable. Remember file system size limits. Basically your repository doesn't only contain the files which you're currently working on, but also all the versions. So that may grow, although Git is very careful into compressing deltas, so basically differences between versions, but still. If you have a remote, of course you don't require a backup. If you only have a local repository, then of course you would like to back up your repository as well. So on VSC systems, typically VSC data is a good choice to store those directories. And to create a local directory, you just cd to the directory you want, for instance VSC data, and then you do git init and the name of your project. And of course you need to do that only once for a project. Once the project is initialized, you can of course just use it. But again, if you have a remote repository, you would just do git clone and then the URL, and you would get started with your local repository, which reflects the remote. Okay, so the single user work item cycle: create and edit files and directories, for instance here a file eq.c, a directory test, and stage new or modified files for the next commit. So that staging is done through the git add command, and you just list all the files and directories which you want to be part of the next commit. So then you commit your changes, so the working copy is now the latest repository version, and this you do with git commit -m with a message, and we'll come back to that message later on. And then basically you continue up to the point when you are done. Okay, that's your single user work item, your single user work cycle for a repository which is local. Okay, now it's important to realize that only the commit affects the repository. So basically you can stage as many files as you like. That does not change anything to the repository. Only a commit does. So a very useful statement is git status. And that basically gives you information about what is changed and needs to be committed. And as you can see, in this case, 2 files are ready to stage, are staged but not committed, so readme and eq.c, and there are also a number of untracked files. So the file todo.md is not part of the repository. It's just a file in the directory in which the repository resides, but it is not part of the repository. So the status command is something that you will probably run pretty often. So by default you're on the master branch, but GitHub, for instance, has changed its naming convention, and now the master branch is called the main branch. So that's a little difference which you might be want to be aware of. So the nice thing about Git is that it's quite verbose and it offers suggestions of what you might want to do next. For instance, suppose that you would like to put todo.md under version control, then it says, well, okay, please do git add. And suppose that you staged the README file but still want to change something else before the next commit, then you can just git remove cached with the name of the file, or with more modern Git clients, you can do git restore readme.md. So basically, you want to know who did what, when, and why, and especially the why is important. Now, Git offers a lot of options in order to view the history of your project, so basically the history of your repository, and that's with the git log command. And you can request the log for a particular file, like in this example for eq.c, and then you get only the commits that affect that particular example, and you can see that I've been changing that particular file on Sunday, April 30, 2017, and the commit message which I gave was that I introduce a square function, whatever. And there is another commit which is a bit earlier, basically the same day, but 2 minutes earlier. And again, you see the commit message, declare constants as such. So basically, probably in the code, there were some variables that were supposed to be constant, but not declared as such. And basically, I'm just pointing out what I'm doing using the commit message. So the git log answers the question of who did something, when it was done, and why it was done. But the why obviously depends on your commit messages. So whatever you put after the -m when you do a commit. So essentially a commit has a revision ID, and that's a hash code, which is typically a very long, seemingly random string, but it is unique to a commit. So every commit is identified uniquely by that revision ID. And a number of commands actually take that revision ID as arguments. But typically you don't have to use all the, I don't know, 20 or 30 or however characters there are. Just the first 6 or 7 of those characters will do in order to uniquely identify your commit. So you can do a git log for a specific file, but also for a directory or for your entire repository. And so basically the answer to why was something committed, why were certain changes made, those depend on the quality of your commit messages. So let's talk a little bit about those commit messages. So the -m option can be used with a number of git commands, and it's a message that describes the current action or the reason for it. That's basically the idea. And that documents the semantics of your actions. So please use meaningful commit messages because they're very informative, and those will answer the why questions. Why was something changed? So they're very useful when developing as a team because you can actually follow the thought process of your colleagues and see why they did certain things they did in the repository. So there are 7 rules for commit messages. And the first one is to separate the subject from the body with a blank line. So the first line of the commit message is just a 50 character line that briefly describes what the commit is about. The subject line should also be capitalized, so it starts with a capital, and you should not end it with a period. And in the subject line, use imperative mood. The body of the commit message, so the more lengthy explanation, should be wrapped at 72 characters. And the body should explain what and why, rather than how things were changed. The how things were changed are easy. You have Git tools in order to see what the difference is, the textual difference between 2 versions of a file. So you don't need to say how you changed things, you need to say why you did it. That's the important point. So you can use commit message templates, and that's very convenient. So it can be either general or repository specific. You can choose that. And the template is typically stored in .git message. So basically, the first line of that template will be filled out, and that is going to be the subject. Then there is a blank line, and then you've got the why. Why did you do certain things? And basically, if necessary, what is the stakeholder of this particular change? Why was this particular change needed? Why was it required? So to configure at repo top level, you just do git config, commit template, and then the name of the template. Typically it's a hidden file, and .git message is a good name for it, but you can take a different name if you prefer. And of course, if you want a global one, then you just do git commit -- global, and it will be a global configuration. So viewing logs is pretty useful. You do that a lot, and there are many ways to tailor the output. A very useful one is one line, and then you get one commit per line of output. And now you immediately see why the subject line is important, because that is exactly what is displayed here. You get an abbreviated hash code for the commit, and then you get the 50 characters of your commit subject. You can also use decorate, and then you get branch info. We'll go into branches later on, but just remember the -- decorate. Another useful one is graph, which basically gives you ASCII graph representation of branches and merges, again to be discussed later. And it works for directories and the whole repository as any git log command. Okay, so there are other things you can do, like filtering for author, for revision range, for date range, and so on. So it's very easy to search the log file and to get the output that you want. Okay, so one of the things which you might want to figure out is what changed, and you can examine change in different ways. So you can do that using the log command, and then basically you ask for a change for a certain revision. You can also compare the current file to the latest repository version, so that's before you actually committed it. Then you can just do git diff eq.c, and that will compare the current state of the file with the last committed ones. Or you can compare it to a specific revision, for instance with git diff revision number and then the file name. So the revision ID is used here many times, and as you can see, you only need to use like 6 or 7 characters of it. If you want to visualize the differences, then typically that is done using git diff, and basically let's consider an example. So on the left hand side you see the state of the file of the commit with that particular commit ID. And on the right hand you see the working copy, and as you can see, a few changes have been made. Essentially the first line has been, well, the first bullet item has been changed, and also the second bullet item, while the third actually remained. Okay, so you can do a git diff commit ID and the file name. And then this is the type of output which you get, which is somewhat cryptic. But you can see that actually the make backups and the comment code line, those have been removed, hence the minus sign. And 2 lines have been added, hence the plus sign, which is the command more code and write documentation. And the lines above, so this is a to-do list, and the last bullet point, introduce less bugs, are basically unchanged. So it's a bit of you need to get used to reading the output of diff, but once you're used to it, it's actually quite convenient. Actually, diffs are not so easy to read, but you can use a visual diff merge tool. And for instance, a good one is Meld, which you can use on Windows, macOS, and Linux. And again, the setup is fairly simple. You do a git config -- global for the diff tool and the diff tool prompt, merge tool, and merge tool prompt. You set those prompts you set to false. And then basically when you do a git diff or a git merge, we'll return to merge later on, actually the Meld application will be used in order to do that in a visual way. So that's much more convenient, and unless you're familiar with the diff format, it is definitely a better way to go. And then you can do a git diff tool rather than git diff, and you get a visual thing. Okay, so let's talk a little bit about revisions. So essentially a commit is a revision. So a new revision springs into life when you do a commit. So a revision is global for a repository, so not individual for files. So if you change a file, the state, the revision, of the entire repository is changed upon commit. That might seem a little bit weird, but actually it's a very good approach. And it was one of the major differences between CVS and Subversion at the time. And Git has the same principle. So the revision ID, I already mentioned, is a pretty long cryptic string, and actually you just need 5 to 7 characters in order to deal with it. So each commit generates a new revision and a single revision ID for everything in the repository at a given time. So basically, if I have a revision ID, then I can reconstruct the state of all the files in my repository to that given revision, to that point in time, and that's very convenient. So let's start with an empty project, and let's just, for convenience, use R1, R2, etc. as revision IDs, so basically as commit IDs, but just because it's a little bit more easy to understand if you use R1, R2, etc., etc. So time goes from left to right. So we start with our project and we add a few files. The original revision was just an empty directory. Okay, so we commit, and that means we have revision 2 with the 2 files committed. Okay, we change one file and we add a directory. Again, we commit, we get a new revision. So basically, the file was not changed, the file was removed. So we now have one file and one directory. We change that file and we do another commit and we have revision 4. So basically, as you can see, the revision reflects the entire state of the project. So not of a single file, but of the entire project. That's the important thing to realize. So when to commit? So of course there is no general rule in principle, but some advice. Basically, a commit is not file safe. So you have an editor, it has a save command, use that if you want to save a file. Not every time you save a file, you should do a commit, definitely not. Essentially, what you may try to think in terms of what you are doing semantically. So basically, as soon as you're able to come up with a good comment for your commit, that might be the time to commit. So one thing which you definitely shouldn't do is commit stuff in the master branch which does not work. For instance, which does not compile without errors. That is definitely a bad idea when you're working with a team. Use branches in that case, but we'll discuss that later. So typically don't worry too much about it. It's a habit which you grow into. So you will probably not do it optimally when you start out using Git, but over time you'll develop some, let's say, intuition for when to commit, for better commit messages, and so on. It's a gradual process, it's a learning curve. You can remove stuff, but if you remove something, you have to make Git aware. Because if I want to remove the file eq.c, and I would just use it, I would just remove it from the command using the command line rm eq.c, okay, it's gone from my working copy, but it is not gone from the repository. So if I want to make Git aware that I want to remove that file, I should use git rm, git remove, in order to do that. So a few things will happen on a git remove. The working copy of that file will be deleted. Okay, that's good, that's what we want. But also a delete is scheduled for the next commit. So a deletion is staged. Renaming a file is similar. So basically there's a git move command, and this will rename alpha.c into beta.c. So it does a move in the working copy, and it also schedules a delete of alpha and an add of beta for the next revision, for the next commit. So basically, all those files which you remove or which you move are still in the repository in previous revisions. So if you remove it and later on you think, okay, that was a really bad idea, then you can simply go back to a previous revision and use that file. So remember to remove files and to move files, rename files, always via git commands. If you don't do that, you get into some issues, because upon your next git command you might get that file back, which you don't want. So there are some things which you definitely don't want to store in your repository, and Git is reasonably smart about what it should add and what it should not add, but you can make that very explicit. And for instance, if you use Vim or other editors that make backup files, you definitely don't want those into the repository. So basically things like eq.c tilde should not go into the repository. You want to ignore them. You also don't want Git to tell you that those are untracked files, because really you don't care about them, you never ever want to see them. And the same, for instance, for certain artifacts or build projects, such as object files, those should also not go into your repository. They're artifacts, they are reproduced each time you build, so you don't want them in the repository. Okay, so for many things Git actually needs some help, and you can create a file .gitignore in a directory, and then you can list files which Git should ignore, and you can use globbing. So basically you can do something like star.back, and then all files that end in the .back extension will be ignored by Git. Or you can have a very explicit name, like for instance a.out, which is the default name an application will get when you compile a file and you don't specify any. Okay, so if you change your mind, basically suppose you've been changing the file eq.c and you think, no, that's not really what I want. So if you want to revert to the latest commit, then you can just do git checkout -- and the file name, and the current file, the current working copy, will be replaced by the latest revision in the repository, so by the last commit. You can revert a file to a very specific revision in the repository, and then you just do git checkout revision ID -- file name. Very easy. And that works for directories, for overrides, for deletes, for created files, etc., etc. You just check out the directory. That's easy. So this is not going to affect the repository. That is going to affect the state of your directory, so your working copy, but not the repository. If you want that change to be permanent, then of course you should commit. First stage, then commit. So if you did a commit and you don't want to, or you already did the stage but you don't want to commit yet, so in the last case you can unstage it. So you do a git add of eq.c, you do some stuff, you change your mind. Basically you need to, for instance, change something more in eq.c, or the file should not be changed for whatever reason. Then you can just do git reset head and then eq.c, so that unstages eq.c. eq.c is not modified by this, it's just telling the repository that, hey, in the next commit, eq.c should not be part of that. And other things you can do is fine-tune commits with that. So changing a commit message is also fairly straightforward. So you did a commit, you had a nice commit message, but there was a typo. It's very easy to change that. You can just change the last commit message using git commit -- amend. And you can also add the file to a previous commit. Again, you can do git add eq.c and then git commit -- amend. So a commit, the last commit, can be amended. Either you can change the commit message, or you can even stage more things and add those to the commit. -- amend is your friend. You can undo a commit of an unwanted file. Basically, in that case, you would do a git reset, soft head, you reset the, you unstage applications.exe, which you staged and committed accidentally. You simply remove it, and then you commit. So undoing an entire commit is also possible. Then you should do a git reset -- hard, and you want the previous commit, so not the head, but the previous one, that's head tilde. So be careful, because that will affect your repository, your working copy, so use this with care, because if you mess up, you will lose information. So, if you want to have a look at the state of a file in a previous commit, you can just do git show the commit ID, and then followed by colon with the file name, and it will just list the file. You can also look at the file at a certain date, so basically git show, and then head add a date, and the file name, separated by a colon. You can also look at a particular commit, so for instance what happened in the last commit, just git show head. In some commit, git show the ID of that particular commit. Some revisions are more important than other revisions. They have special significance. For instance, in the context of software projects, those might be releases 1.0, 1.1, etc., etc. In scientific projects, versions could be used in order to generate data for submission. And then, of course, that particular commit, which was the last one, which was used to generate that data, is also very significant, because you want to reproduce potentially your results. So in that case, you can tag a commit, and that is just git tag followed by some string. In this case, I use 1.0 because I'm assuming that this is a software project and the first release, but you can do basically anything. And it's very easy to later on use a tag in order, for instance, to see differences. Git diff 1.0 will give all the differences between the current working copy and that particular tagged version. So Git provides quite a lot of help, and typically it provides suggestions for next steps to take. We've already seen that. But there's also extensive help for each command. So basically Git help is very general, and you can get more information on specific commands, for instance by using git help add. That would give you specific information for add. So this is quite useful, and the help is actually well written. So that's quite helpful. Sorry for the feeble pun.